Good evening, YouTube. Welcome back to the channel. Back with another episode of Python Koans. Hope everyone is having a good week. Let's get into it. So this is the next installment, and I'm going to go ahead and run. Let's see, what file am I actually trying to run here? Let me make this a little bit bigger for everybody. We are trying to run contemplate Koans. So Python contemplate Koans. I don't have Python. I need to run Python 3. And if none of this looks familiar to you, head back to the first video where we talk about setting all this up, getting Python installed, getting the Koans installed, etc. All right, so where are we? Looks like we are in a file called Thinking About Tuples. And that is in users showtop programming Python Koans master Koans about tuples.py, and we're on line 9. So let's just do a Command T here in Sublime Text and go to about tuples. All right, and our first failing assertion is right here on line 9. So we're going to have to make this test pass to move on to the next one. What is a tuple? As far as I remember, what is a tuple? Tuple is like a list, but it's a little bit different than an array. What is a tuple? A tuple is an ordered and immutable collection of items in computer programming and mathematics. Unlike lists, tuples cannot be changed or modified after they are created, which is known as immutability. They are enclosed in parentheses in Python and are useful for storing a fixed group of related data, such as coordinates like 410, or database records. All right, good to know. So let's see. Looks like we have on line 8 here, first of all, we've got a test. We've got a series of tests. And the first test starting here on line 7 is called test creating a tuple. And on line 8, we've got a variable, and it's set to what appears to be a tuple with the integers 1, 2, and 5 inside. Let's see. Count of 3, 2, assert equal. Well, that's interesting. I don't know what count of 3. So this structure here where we can call the sort of index type bracket structure on a tuple, what that will return. I wonder if it will return the second item actually the third item in a zero-based indexed tuple. So I'm going to say 5. That's my guess. I really have no idea. So this is going to be like, oh, give me the 0, no, the first, no, the second item in this tuple, which in this case would be 5 because, again, it is zero-based. This is all me guessing. So let's run it and see what we get. All right, so that was correct. We are now looking at line 22, so we have moved further. So I was correct about that. The way that you pull an item out of a tuple, it appears, is with this syntax, and you pass it an index that says pull me the item or give me the item that is at this index. All right, and in this case, in the tuple by the name of count of 3, the item at the second index is 5. Next test. Test that tuples are immutable, so item assignment is not possible. All right, so again, on line 13, we've got a variable set to a tuple with 3 integers, 1, 2, and 5. Then we have a try-catch construction. And in this construction, some code will be tried or attempted. And if an error is thrown during the processing of that code, that error will be caught, and we can manage how it manifests. Typically, if an error is thrown, the program just stops and everything stops. You get an error. But if you can catch that error, you can catch the exception, you can do other things with it. And that's what's happening with this try sort of try-catch setup or construction. All right, so we've got a try-catch where we say, all right, at the second index of the tuple, set that thing to the string 3, all right? And I assume that will throw an error because tuples are immutable. You can't, once they are set, you can't reach in and change one of the values inside. So then we'll capture any type error exception, and we'll save it to a variable called ex. And then we'll say, here's a message. Because we'll save the error to a variable called message. And then it looks like down here we need to define, in order to make this test pass or this assertion pass, what that message is. And here's a note. Note, assert regex uses regular expression pattern matching, so you don't have to copy the whole message. I got it. All right, so let's see what the error is. First of all, let's do this. Let's go to a new tab, and we'll say Python 3 to set up our IRB, our interactive Python interface. All right, and then let's run some of this. So actually, let's just paste this whole thing. And all right. Oh, now that's silly. Let's just try this. All right, so let's just see. Okay, we'll set our tuple. Here's our tuple. And now we will simply try the error clause and see what error it generates so that we know what to put into our assertion. Okay, so we've run the error code where we tried to set the second item in the tuple to, or the third item in this case, to the string 3. Python threw an error, and it says type error. Okay, so that's the class or the type of error that it is. The type of this error is type error. Tuple object does not support item assignment. All right, so then let's just grab this. And we need to match some subset of what I think will be the message. So let's do that. And we'll do double quote, I think, right there. Double quote there. Let's see if that works. So we'll jump back over here and we'll run it again. And that was correct. So we captured the error, and then we generated the error to see what the captured error would need to match to get this test to pass. So I hope that made sense. That's kind of a more complex construction, this try-catch thing, than we've seen so far. So ask any questions you might have or watch again to really kind of get an understanding of that. All right, line 24, next test. Test tuples are immutable, so appending is not possible. This is going to be a very similar thing. Let's see. So we've got a variable on line 25 set to a tuple with 3 integers, 1, 2, and 5. And then we say with self assert raises, count of 3, append, boom. All right, so tuples are less flexible than lists, but faster. That's good to know. I'm going to say this is going to raise, I don't even know, but I'm going to say this is going to raise a type error. And we'll see if that's correct. And what this means is assert or verify that when the following code runs, this code in question, verify that an error is raised and that the type of error that's raised is, in this case, type error. So similar to the way it was raised up here, where we caught the error or caught the exception, only if it was of class or if it was type error. Let me just run this again and see. All right, so you have not yet reached enlightenment. So that was not correct. Okay, so you have attribute error, tuple object has no attribute. Oh, so it must be attribute error. Let me try that and see if that's correct. Run it again. And that was correct. All right, so if you try to append to an immutable tuple, which they are all immutable by default, and you call the append method, like is happening here, the error that will get thrown is an attribute error that says, hey, you're trying to call append on me, but because I'm a tuple, I don't have that method, or you don't get the ability to call that on me, and therefore here's an error. All right, so tuples are less flexible than lists, but faster, okay? Test. Tuples can only be changed through replacement. Interesting. All right, so again, our same tuple setup here on line 31, set to variable count of 3. All right, so a new variable on line 33 here, list count, is set to a list of, so it looks like we have cast our tuple to a new object type, which is a list. And remember from previous files we've gone through, lists are mutable. We can replace items, add items to the end of the list, etc. So that looks like what might be happening here. So let's see. So we have converted our tuple to a list, and we've saved that to a variable called list count. Now we are appending boom to our new list by calling append on the variable list count and passing in something that we would like to append to the end of it, which in this case is the string boom. And now we are saving that object converted back to a tuple to the same variable count of 3. So what does now count of 3 equal? I'm going to assume that it equals a tuple like this, but that has 1, space 2, space 5, and oops, and the string boom. I bet that's what it is currently. Let's see. That is correct. We are now down to line 40. So that was correct. So it says the test that tuples can only be changed through replacement. And in this case, replacement means create a tuple, convert it to a list, make the changes that you want to that list, and then convert the list back to a tuple. And that's how you can make changes to your tuple. All right, next up. Test tuples of one look peculiar. Okay. Tuples of 1. I mean, so of a single item, or even the integer 1. Maybe that's what they mean. So assert equal something equals to whatever the class of this thing is. And this thing, it looks like a tuple with a single integer inside. What is the class of that? I assume it is of class tuple. Let's see if that's correct. So does line 40 pass? No, it does not. All right, so interesting. Maybe not underscored, lowercase. Maybe lowercase? No. Assertion error does not equal class int. Interesting. So this thing, weird. All right, so I want to check that out actually. Let's jump over here. So if we take this, let me go down, and we put 1 in there, and then we say dot underscore underscore class underscore underscore. It's of class integer. That is bizarre to me. What if I do a tuple with like the string one inside and I say dot underscore class underscore underscore? That's of class string. Okay, that really doesn't make a ton of sense to me, but let's keep going. All right, so 1 comma. I wonder if that's going to be a tuple. Let's try that. 1 comma, and that is correct. So if you have a pair of parentheses and you just put an item inside of there, the type of that thing or of that object is whatever the type of the object inside is. And in this case, it's the integer 1, so this type is integer. However, if you have a pair of parentheses and you put an item followed by a single comma, it looks like Python interprets that construction as a tuple, not as an integer or a string or whatever other data type you might put in there. All right, so let's look at this one. All right, so here we've got a string inside that says I'm a tuple, and notice it's followed by this comma. And so I assume that when we call .class on that, what we get back will be tuple. And now this one, very similar construction, a string inside of not a tuple, but no follow-up comma, all right? No comma here. And therefore, I would assume that based on what we just talked about, this will be string. Let's see if these all pass. And they do. We're down to line 46. So that's interesting. I would have never guessed that. Test that tuples of 1 look peculiar, and they do because they're just an item with a comma after them that looks like it wants something else, but very interesting. All right, line 45. Test tuple constructor can be surprising. All right, so we're saying assert equal something is the result of what you call when you do tuple with something inside. And I have no idea what this is going to be, but I wonder if this returns a tuple with the string that was passed to the constructor, surprise, and then maybe just a single comma based on what we saw above. Let's run it and check it out. Did I spell everything correctly? S-U-R-P-R-I-S-E. All right, let's try that. So does line 46 pass? It does not. Oh, weird. That is bizarre. So we can see, like effectively we see what the answer is. Like this is what you gave the assertion, and this is what it expected. And so what it expected is kind of crazy. This constructor takes, if you pass it a string, it looks like, it takes that string and splits it into individual strings and then returns that tuple of individual strings like we see here. I would have, again, not expected that. So this is incorrect. This is incorrect. So let's do, we've got a tuple with this item, U, R, P, R, I, S, E, exclamation point within a string. All right, so let's try that again. And there we go, line 46 passed. So the moral of the story, test that tuple constructor can be surprising. It is surprising. I would have expected this constructor, meaning passing this thing right here, an argument of a single string. I would have expected it to return a tuple with that single string as the single item inside the tuple, but no, it splits it up and gives you a tuple back with each individual, a series of items made up of individual characters in that string. All right, so what's up next? Test creating empty tuples. Okay, so how do we create an empty tuple? Well, maybe we can, I don't even know. Can we just say tuple and give it nothing? And then, yeah, I don't know. Let's see. What does 49 pass? Okay, so 49 passed, so that is true. If you call tuple with nothing, you get an empty tuple back. Let's confirm. So if I do this, whoops, and I call underscore dot 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 class, it is class tuple. Okay, so a pair of empty parentheses is of class tuple in Python. Assert equal, I don't really know what they want here, but I guess it's just a pair of empty parentheses. I keep doing that without the shift. Let me see. Not that. We want to go back over here. All right, we are line 56. So that is correct too. So these are just like the opposite, it looks like. Sometimes less confusing. Yeah, maybe. All right, line 52, a new test. Test tuples can be embedded. Okay. So we've got on line 53 a tuple set to a variable lat. And then on line 54, a tuple set to variable lon. Line 55, a tuple set to variable place. Area 51 that embeds the previous two tuples. Now we're going to assert equal. So what does place equal? I think what they want is for us to take place and replace the values for lat and lon with the actual embedded tuples themselves. Let's try that. So you can have a tuple of tuples, it looks like. Let's see if that's correct. Does line 56 pass? It does. All right, so that was correct. In this situation, we have two variables, lat and lon, that are set to tuples. And when we write out the full object here, the full tuple, those lat and lon, of course, can be expanded or replaced with their actual values, which are additional sub-tuples. Kind of interesting. All right, the last test on this file, line 58. Test tuples are good for representing records. Okay, so now it looks like we've got a list with two items inside, and those items are tuples with tuples inside them. And that list is set to a variable called locations. All right, on line 64, we're going to add another tuple to our list, our locations list, using the method append. So we'll call append on our list and then give that append an argument that represents what we would like to append to the bottom of the list. All right, now let's see. So with this thing embedded or placed, appended to the bottom of the list, we will say, I don't know what's going on here. So we have locations. We are now calling two indices or indexes. I'm not really sure what the proper plural is. I think it's indices. So it's saying, okay, give me the second item in the locations list. Again, they are 0-based, so you'll get the third item. And then give me the first item in a 0-based tuple. What does that equal? All right, so in our locations list, we have added a new item, and that actually does end up being the item at the second index, 0, 1, 2. So we know we are working with this data structure. What is the first item, the 0th indexed item, in that data structure? And I believe that's going to be the string Cthulhu. Let's try it. This is the 0th item in the second item, Cthululu. Let's see if that works. Does assertion at line 66 pass? It does. We were correct. All right, so now locations. All right, so give me the, in the list of locations, give me the first item at the 0th index. And so that will be this one right here. Then give me the item at the 1 index. And so that's going to be, so we're working on line 60, only on line 60. That's the data structure we're looking at. The item at the first index is going to be this one here. All right, it goes 0, 1, 2. So here after that first comma is the 1th, the first. And then give me the second item in that structure. So in this tuple, what's the second item or the item at the second index? It's 0, 1, 2. So it looks like it's the float 15.56. So let's go ahead and try that. 15.56. And we'll see if we pass, which we did. All right, so that was all about tuples, which is cool. There's the message. Namespaces are one honking great idea. Let's do more of those. All right, so we're only about 25 minutes in. Let's do a little bit more of this next file. So we've moved on to another file. We've completed 23% of the Koans, 8 out of 37 lessons. You are 232 Koans and 29 lessons away from reaching enlightenment. So we're almost there, kind of. All right, about methods. So let's do Command T, about methods.py. All right, so this is partially based on the about methods from the Ruby Koans, okay? Now, interestingly, we've got a global function defined up here, okay? And what does that global function do? It takes 2 arguments, A and B, and then it returns those 2 things, whatever are passed in, the sum of them. It adds them together. So we've got a new thing, a new class about methods. We're going to learn about methods. All right, so the first test here, calling a global function. All right, we just talked about this global function that exists here. Assert equal my global function to 3. And what does that return? Okay, wrong number of arguments is not a syntax error, but a runtime error, okay? So if we passed these 2 arguments to our global function called my global function, which is defined right here on line 10, and we know that it takes those 2 arguments and adds them together and returns the result, what did we get? I assume here we'll get 5. Because that is the result of 2 plus 3. So let's see, does line 15 pass? And it does. Sweet. All right, next one. Test calling functions with the wrong number of arguments. All right, so the wrong number of arguments is not a syntax error, but a runtime error. And what does that mean? Like, let's say, for example, we go back to my global function. My global function says, okay, give me 2 arguments, A and B. Whatever you pass in this list of arguments that you give me, like we are here, I'll add them together. But let's say we called it with 3 arguments. It doesn't know what to do with the third one, and it would throw an error. But as according to this note, whoops, it is not a syntax error, it's a runtime error, all right? So that might come into play in a bit here. So test calling functions with the wrong number of arguments. So we're going to try to call my global function again, this time with nothing passed in, so it has nothing to add together. We'll capture an exception as long as it's of type error, and then we will capture the message that's associated with it. Note, the text comparison works for Python 3.2. It has changed in the past and may change in the future, okay? So we're going to do an assertion that says, hey, assert that, I see, that the error that is returned says you're missing 2 required positional arguments, okay? All right, and so then we do it again, and we literally do the thing we just talked about a second ago, where we call it with more than it needs instead of less. Now, note, watch out for parentheses. They need slashes in front. All right, so then I assume we're going to get this whole thing that says you are passing more than you need. So let's see what it potentially could look like. I'm going to assume that it's going to be like something like added too many positional arguments. Let's run it and see what we get. All right, regex did not match. All right, so we said assertion error, regex didn't match. Okay, yeah, my global function, blah, 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 added too many positional arguments. All right, that's what the error message I assumed it could be. What does it actually say? Not found in my global function takes 2 positional arguments, but 3 were given. All right, so we want this. So this is the error that you actually get when you pass too many arguments to a function. Line 36. Still failing. All right, so what I think we need to say is let's see. I kind of want both of these so I can see them side by side. All right, and now I want to fill this one in correctly. All right, and now we want to make this all look similar. So that all looks similar, but 3 were given. All right, and then we can get rid of this. Let's see if this passes. So does line 36 pass now? Yes, it does. Okay. All right, so if you call a function and you don't give it the required number of arguments, you give it fewer, it'll say, hey, they're missing. If you give it too many, it says, hey, I only take 2 in this case, but you gave me whatever you give it. All right, going a little bit further. So on line 41, we've got a new method called pointless method, and it takes 3 arguments, some object, and then an A and a B, and then it returns the sum of those 2 things. Test which does not return anything. Okay, so assert equal, we call this pointless method and we give it 1, 2. Notice that methods accessed from the class scope do not require you to pass the first self argument. Okay. Do not require you to. So I'm curious, does this return 3? line 45. It does not. So, looks like it returns none. All right, so then the question is why? Notice that test which does not return anything. So we called pointless method. We did not pass it all the arguments. But if we pass this in, does that work? Huh. No, that's not how that works. It's not super clear to me why this returns none. Notice that methods accessed from the class scope do not require you to pass the first self argument. I see that. So you don't have to pass that in. That's already there. And from the class scope, meaning within a class, you don't have to explicitly pass in this self argument. But why this method returns none, I'm not sure. If you do know, please let me know in the comments. All right, so method with defaults. In fact, let me just try this real quick. Sum equals, oh, you know what? All right, now let me try this. Pointless method. I think I know why it's pointless. Oh, and in this case, we're not in a class. So I think this is pointless because there's no return. Is that right? Notice how these other methods, they say return something. For example, let's just do this again. We will not worry about this thing. So A and B. I don't know what this is doing. Def, pointless. It takes A and B. And a colon. And it does sum equals A plus B. And then we say pointless, and we give it 4 and 5. So we would expect 9. But this is going to return nothing. Nothing. Why? Because all we did was take the two arguments and set them to a variable. There's nothing to return. Now, if we were to say, okay, return A plus B like we do right here, you would get something back. I think that's what that means when it says pointless method. Like this has done nothing. It gives us nothing back because all we've done is assignment right here. There's no return statement. There's nothing that is given back to us. And the other thing that they are pointing out is that within a class, I think this is probably how you do class method, but anyway, that probably comes later. But you don't have to, despite the fact that in the method signature, self is an argument, you don't have to send it in as an argument when it's invoked. And notice it's called on self. So this is a class method. It's a method that you call on this class itself, not on an instance of the class itself, which we will get to, I think, a little bit further down the road. Okay. Pointless method. All right, method with defaults. This will be the last one. So a method with defaults. We've got a class method with defaults, and it takes 3 arguments. The first one is we don't need to worry about in this context. The second one is A. The third one is B. and that B is set to a string called default value. And we explicitly return a list with A, whatever was passed in when the method was invoked, as the first item in the list, and whatever was passed in the position of B, the second item in the list. Now, test calling with default values. All right, so we're going to call our method with defaults, and we're only going to pass it one argument, and this will get mapped to argument A. Previously, if we called a method and we didn't pass in the correct number of arguments, we would get an error. But because in this method signature we have established a default value for the second argument, we don't have to call it. And what I think will happen is, instead of getting an error, it will return a list, like is defined here on line 52, a list with the thing we passed in as A. And then if nothing is passed in for B, the string default value. So let's see if line 55 passes. Go back over here. Line 55 passed. All right, sweet. Now, again, similar. This time we are actually invoking the method with the appropriate number of arguments. And this time we've passed in our own in the B position. So what will happen there? I assume the default value will be overridden, and our value that we are passing in will get placed there instead. So let's see if that's the case. That is the case. All right, so we did some tuples. We got into methods. So these are, of course, very important fundamental concepts in not just Python, but in all programming. And so it's very interesting to be talking about these things at kind of like a fundamental level. Every time I do one of these videos, I learn a little bit more about some of the strange nuances of Python. It's very interesting. All right, so anyway, have a good night, everyone. Everybody enjoy the rest of your week, and I will see you all in a few days with probably another networking video, but we shall see. Hope you all have a good night. Thank you. Bye.